welcome back to the channel. I thought in this video I'd try something different. I'm working on building this Cacophonator, it's called. And I thought I'd try and document the process. Got to this quick stage of the prototype. I thought we'd see if we get it from here to something a bit more permanent. I've got a tin. Let's get that over there for you. It's in there, you can't really see it in there. Yeah, but we do the whole process. So at the moment, this is what we've got. It's yet another CD 4106, sorry. And then a lot of inverted Schmidt triggers based around there. I want to begin with to figure out this section here. This is meant to be a big discharge capacitor, and it does. Well, I'll show you what it does. So this is it switched off, and then if we switch it on, you can hear it's doing it, making noises. Oh. This potentiometer here is for the flow, the current flow. But then this button here doesn't seem to do anything. If I switch it off, so we get this sort of winding down, you can see the LED diminishing, and then we can still make some effects. But I want to check, because I'm not convinced I've done this button right. So in this video, well, in the video we're going to do the whole thing, but in this part now, I'm going to have a look at that. And I'll see what I can get on with. So I'll crack on with that and see if we make any changes, any progress for that. Right, stay tuned. Okay, I think we're making some progress now. I've rearranged this whole section up here. It follows, I believe it follows the schematic a lot more. This diode I've had to make do, because it's asking for MUR 210G, which I can't find an alternative to. So I just looked at what it does and stuck one of them in. Right, so the button doesn't, there we go. We charge it up with just the button, it's still switched off. But then if we switch it on, we've got power coming from the battery now. We're going to use it and switch that off again. And now it's just going on off the discharge from the diode, from the capacitor, sorry. Which we can press the button, put power back into there. And now it's discharging again. Fire that up again. So now I'm going to leave it to discharge completely, which can take a while sometimes. I've noticed when I timed it, it took a minute once. Oh, that's an interesting noise. So that's almost silenced. Press the button. Power's going back through to that. There we go. Let's see. What happens if we put another capacitor in there? The 1000 is the biggest I've got. Where are we? There we are. So we'll bang this in and see what this does. Pop it there and just put a jumper across. Find my jumpers, there we go. No idea if this will make much difference. Should do, because it's doubling the capacitance there. Right. So let's see what that does to the discharge time. So it's all off, everything's off. It's going for a long time, that. This one might be interesting. If we pop a little switch in there, then we can change the capacitance, can't we? How do we do this? Let's go this way round. So currently that's set to just the one capacitor. So it should just be charging up this one here on the left. But then, well, that made a difference, didn't it? So now it's got both of them. Change the switch over, charging up both capacitors now. Now let's see what happens when we change this. I wonder if it's going to hold some charge in there and we can switch across. It does! Okay. Go down to that. I've got across, I'll charge them both up. So I should be charged now. Switch that across to just the one. Now that's discharging. Now go across to both. And we haven't actually switched the thing on. In fact, actually the ground's come out here. Okay. Okay, that's interesting. Right, I'm gonna have a little look at this now, because right. Okay. Stay tuned, I'll be back shortly and we'll have another look at this. Okay, so we decided we'll time it and find out what difference it's making. So we're going to time, using the button to charge it up, one capacitor for 5 seconds and then time the discharge. And then we'll charge up both capacitors for 5 seconds and then charge the discharge. So I've got a timer on the computer screen there. I'll put the times on the video as well. So here we go. We'll charge up for 5 now. And then ready, go. So that's charged for 5 seconds. And we'll see how long that goes for. Not touching anything at all. I don't know if you'll be able to hear the full discharge. It's still going on 22 there. Just struggling now. Cutting in and out a little bit, but it's still going. And there we go. So that's 38.5 seconds. So a 5 second charge with one capacitor is a 38.5 second discharge. Right, let's reset that. Switch it to now charge both capacitors. See what we get now. So start, and again 5 seconds. Right, and now we're discharging. What was the previous one? It was 38 seconds. I don't know if it'll make much difference. I doubt it'll double it, will it? But we'll see. So this is 22, and we're still going. Still going strong. So now we are past where the previous one was. We're still going. So the previous one was 38, but we have to take 5, so 33. This is 50 now. Oh, sorry, 47. Now it's 50 seconds of discharge. 55. Can we get to a minute? That's a minute of discharge. Bloody hell. 1 minute and 6. So it is double. Oh, it's final little gas for air there. Right, that's interesting. So the first one, we charged it for 5, and then I misread the time on that. Let's just retest that. Let's get it proper, shall we? We charged for 5, and then it discharged for 33, because I said 38, but that's just a big number and I got confused. Right, let's try it again. So it's set now to 1 capacitor again. Let's charge it for 5 and then get a proper reading of the discharge time. So this is a charging, and there we go. Let's see if we can get the same result. If we can, I think then we can say we've done a nice job of this. So that's 15 seconds, so that's about halfway. It seems to be struggling a bit more this time. We're still going. 25. 30. Yeah, it's the same. 33 seconds. Right. I think I'm just going to whack an LED in just to see. Just want to make sure that doesn't affect anything. Sometimes it draws power to places where you don't want it to. It can really affect the sounds, and I don't really want to mess about too much with that. So let's have a look here. Why can't I work this out? There we go. So, how many tweezers? I've got these tweezers and a couple more sets. There's a shop near us that sells old medical supplies. So these are old medical tweezers, and they're very, very, very useful. Okay. You see this LED is just in, it's just for power, just an indication. Yeah, that's still fine. Switch it on, that's on both, so there's the power. This looks something, isn't it? I think that little squeak there must be that second capacitor charging. Oh, interesting. Right, switch that off. Right. Okay, stay tuned, we'll come back and we're going to start soldering something up here. Come up with something more solid. Okay, so before we start soldering something up, I'd like to try and finalise what the layout's going to look like on the top of the tin or the box, whatever it is we're using. For this one I thought I'd use this old sweet tin. Yeah, it's from a company quite local to us here in Stockport. So it seemed quite fitting, and there's plenty of space there because we need 7 dials, a button and 2 switches for this one. I wanted to use these safety switches. They've got a nice heavy duty on off, single pull, single throw. So I'm just going to try and work out the layout here. In fact, actually, we could end up putting another dial on for the volume. So it's going to be 8 dials. So we need our 6 oscillators. We should have something along these lines. And for the button, there's the big button on there, but I can't quite decide. Quite these little momentary switches, momentary buttons. So I'm thinking something like this, maybe. If we have one of these, say for the volume, this one to control the flow from the battery into the circuit. Separate these a little bit, and then perhaps this button there, and our little single throw double pull for the switching between the capacitors there, and then an output jack on the back there. Something along these lines. It'd just be nice because we can still read the box details. Oh, we're going to need an LED as well, aren't we? Let's grab an LED. What colour? Blue. Blue. Oh, should we try something different? Let's try green. Green might be a nice change. I'll probably use a smaller one than this. The power. If we have a light for the power. So if we have that button there, we can maybe have the power indicator there, I suppose. So that's what I'm thinking for the layout. Yeah, because then we've got all the voltage and volume over there, and then the oscillator controls over here. Right, yes, we're happy with that. I'll take a picture of that so I don't forget, because I can guarantee as soon as I move it, everything will fall down, and then get to soldering, I suppose. Okay, decided to use this whole bit of strip board. I know I should probably trim it down, but I like to have a bit of extra space because I'm still learning. There's loads of room in the tin for this, and it means we don't have to worry too much about getting everything perfect, you know, for use, maximising the space. So if I made another one, I would make it smaller, but this is still a prototype. So first things first, I'm going to get the holder for the chip on, and this little battery clip, just so I know where we're working, where everything's going. I can work around from that. So I'm going to make a start on that. I'm not going to talk through the whole thing. I'm just going to crack on, do a few, you know, speeded up sections. I've got a nice hot cup of coffee, soldering irons up to temperature. So I think it's time to get on. Right, I'll put some music over the top perhaps and sit back and watch some messy soldering. And next time we come back, hopefully, we'll have something we can test to see if it's working. Oh, right, so it's a few days later now. I did intend to film the whole build, soldering up of it, but I forgot, to be honest. So that's only the short little fast forwarded bit you saw before. And now we've got this, a Cacophonator, and it appears to be working. Uploaded a little short of it yesterday, but didn't really do it any favours, I don't think. So I think the best thing to do is just to fire it up and have a play about. So we've got a main power. I like these big power switches like that. So that brings it to life. This switch here is for the two capacitors, so that charges up both, and that sets it to just one for the discharge, and then we can rather play about with that. So these oscillators these two don't do anything while this is settled there, and you can mess around with that. So this is controlling the amount of current going through. These two have a small capacitor, these are a medium sort of capacitor, and these two have the bigger capacitors. And if we shut it off, this still works. We can let that run down. The light goes off. That sets it to the second 1000 farad capacitor, or we could charge them both up. It still has quite a large discharge time as it did before. Mess about with these, you get some interesting beats and patterns happening. We could just have some fun. And that's it. Cacophonator. Just needs a few labels on for the different dials and switches, and yeah, I think we're good. Thanks for watching. If you've made it this far, fantastic. If you're subscribed, brilliant. If not, please do. Start the next project now, which is going to be an Atari Funk console, hopefully. I'll live in this, and this is one I'm going to try and get on Etsy to sell. Got a prototype just over there out of the way. A few little issues with that, but we're getting there. And yeah, thanks for watching. I'll play about with this, and see you next time.